Let's consider a particular case for the voltage around a point charge of capital Q. And we would like to ask, what is the expression for the voltage at any location nearby that charge capital Q? Remember that voltage is related to the amount of work to be done to bring another charge, little q, in to that somewhere in proximity of the charge capital Q. We'll assume in this case that we started out at a distance r infinitely far away, and we're going to move into a distance r, little r, equal to some final value, capital R. We know that the electric field around a charge capital Q is equal to k times capital Q over r squared times the unit vector r, which points away from Q. Therefore, the force on little q will equal to little q times this electric field. When we ask for the work to be done to bring the charge little q in from very far away, in toward the charge capital Q, that will become the integral of little q times k times big Q over r squared times r hat, because this is right here, the electric field, dotted into the displacement. Well, the displacement is moving in the negative r direction as we approach the charge capital Q. The r direction being pointing out away from capital Q. This results in an integral starting from r is infinity up to little r equals to capital R of kq over r squared times little q times dr, and there's a minus sign in front. If we evaluate that indefinite integral, 1 over r squared integrates to 1 over r, and we're evaluating that integral at the limits of integration from capital R down to infinity. This equals k times the product of the two charges times 1 over capital R minus 1 over infinity. And since infinity is infinitely large, that second term is 0. The work to be done then is k times big Q times little q over capital R. And the potential energy is the negative of work, or minus of that value, and the voltage will equal k times capital Q over R. These are two formulas that it will be very helpful to remember in the future. Even if you can't remember the derivation that we just did here, it is important to know that the voltage around a charge capital Q at some distance capital R is kq over R.